Hi, I'm Shelby Westerberg. The goal of my project was to create a distraction destroyer Pomodoro timer, which only continues timing if the photoresistor on top indicates that the object placed on top of it has not been removed. As an individual project, I was responsible for designing and implementing all blocks in the system, including the power supply, the inputs, the input decoder, the state machine, outputs, and the enclosure. It was both challenging and rewarding to learn to implement so many different kinds of blocks. For instance, I'd never used CAD software before, and I learned to create an electrical schematic, design a PCB and route it, and design an enclosure. Additionally, I learned to implement I2C procedure in the Arduino programming language in order to interface with the 4 7-segment displays. I considered the opportunity to learn so many new skills during this project a key achievement in completing this project. In the future, I would like to improve upon this project by replacing the entire microcontroller Arduino Nano with only the AT328 processor, that is its brains, and any necessary peripherals to both reduce the production costs and the minimum enclosure size.
The purpose of the Pomodoro timer is to incentivize the user not to pick up their distraction object, usually a smartphone, for the duration of the time set on the timer. If they do, the timer will go off and must be restarted from the beginning, encouraging the user to stick to their planned focused time while using the Pomodoro method, which alternates 25-minute sections of focused work with 5-minute breaks. A photosensor on top of the timer detects whether the object placed there remains there. The alarm for the timer is a 440 Hz tone between 60 and 70 decibels, so it is noticeable and yet comfortable. The inputs to the system allow the user to dim the brightness of the screen using that potentiometer knob, select a time from the 2 available options using a toggle switch, 25 minutes and 5 minutes, so the user can follow the Pomodoro study or work method, and of course the press button to start. The major functional blocks in the system are shown here. Only the inputs, outputs, and enclosure blocks are accessible from the outside of the timer. Both the input decoder and state machine blocks are contained entirely on the Arduino Nano microcontroller. However, due to their different functions and ability to be designed and tested independently, they are represented separately. The power supply currently in use is a 5-volt rechargeable battery connected to the USB port on the Arduino Nano. However, swapping this out for any other valid power supply for the Arduino Nano through its VIN pin will not impact the functionality of the timer, so long as the power supply can supply at least 200 milliamps at a minimum of 4.75 volts. The input and output devices in the system all plug into connectors on the custom printed circuit board shown here, which also houses the Arduino Nano microcontroller and some of the necessary pull-up, pull-down, and current limiting resistors for the various input-output devices. Because these peripherals are connected in this way, they could be switched out or replaced with similar pieces with little difficulty, or detached from the system altogether. Utilizing a printed circuit board also made the circuit smaller, neater, and easier to mount inside the enclosure. To achieve fast response time to inputs from the user, while maintaining an accurate record of the time elapsed, I utilized the internal interrupts on the Arduino Nano. This allows the microcontroller to continue working on other instructions until the interrupt is triggered, and the microcontroller switches momentarily to an interrupt service routine to update counters tracking the current time remaining. This means that updating the LED display and pulling the inputs related to the photoresistor and dimming knob does not affect the timing, and that the microcontroller has more time available to do these tasks because the timing is happening mostly in the background on hardware specifically for timing. The opportunity to design, build, test, and troubleshoot both the hardware and software portions of this project have helped me to maximize what I could learn from it. While difficult, I am delighted with the resulting product. In particular, the printed circuit board design was an entirely new skill I had to learn, and while the resulting printed circuit board has its limitations, it is an invaluable part of the timer, which allows it to be more easily modular and better integrated into the enclosure with fewer crossing wires. One key limitation to the timer being as useful as possible is its size, as seen here, which many users may find unwieldy. The next stage of this project would include as much as possible of the hardware on the printed circuit board to minimize space taken up by extra wires. The next stage of the project would also use a different power supply, which does not require a relatively large USB cable that using the battery pack attached to the Arduino requires. Additionally, switching out the full Arduino Nano for only its processor and other specifically necessary components, such as a voltage regulator, would reduce the total size of the electrical components, allowing them to fit neatly into a more conventionally sized timer enclosure.